Welcome to this unit in which we are going to talk about string processing. And in the Jack operating system, strings are handled using a class called string. So as you see, we are inching our way through the operating system, one class at a time. And you have to admit that this module has a lot of class. So let's start with this string class and take a look at its API. And we'll see that we have a constructor designed to create new strings of a given length, something which is supplied by the client program that uses this service and wants to create and manipulate strings. Then we have a disposer, quite naturally, as we should have in every class that creates objects. We should have one that knows how to destroy them and recycle their memory resources, which happens all the time with strings. Then we have an accessor that returns the length of the current string. And we have a method called char_et, which returns the character in the current in the given index in this in the current string. Set_char_et, which sets this character to some desired integer. To some desired character. And we have an append_char, which takes the character and appends it to the end of the current string. And then we have a set of additional methods like erase the last character, provide the integer value of the current string, assuming that the characters in the current string are digits. And we have setInt, which takes a particular number, integer value, and turns it into a string. So a value like 123 becomes the three characters that represent the digits 1, 2, and 3. And then we have three more methods that return the the ASCII values of new line, backspace, and double quote, which is convenient to have because, well, first of all, programmers routinely forget what these values are, and there's no reason in the world to remember them. And second of all, if you use these method calls instead of actual constants, your code will be far more readable. So these are the methods or the API of the string class. And you may ask yourself, where these method names and structures and signatures came from. Well, when we designed the operating system, we decided to use this particular API based on our experience and taste and whatnot. And in fact, this API is quite similar to the API of the string class in other object-based languages, although there are some syntactical differences, of course. But in essence, it's pretty much the same thing. Now, before we open up the string class for implementation discussions, I'd like to illustrate how strings are actually being used. So let's take the perspective of a client, and here's some client code that creates or actually declares a string called s and an integer variable called x, and then the client goes on to construct a string which has the maximum length of 6 and the actual length of 0 because it contains no characters yet. And now the client appends the character 97 to s. 97 happens to be the ASCII code of A, and so now the string contains the code, the string A. If we now append 98, the string becomes AB, ABC, ABCD, just follow what the client code says. If I now ask what is the length of this string, I get the number 4, which is the actual length. Once again, not the maximum length, but the actual length, which changes all the time when you do string manipulations. And here's an example of starting with an integer value, 314, some 16-bit value, and turning it into the three characters 3, 1, and 4, which internally are stored as three ASCII values. So what you will actually see inside the string now is the ASCII code of 3, which I think is, let's see, the ASCII code of 1 is 49, so it's 49, 50, it's 51. So we'll see the number 51, which is the ASCII code of 3, and then the number 50, which is, I'm sorry, then the number 49, which is the ASCII code of 1, and then 53, I think, which is the ASCII code of 4. The details are not important, right? But you have to understand the difference between a binary value that represents an integer value and 3 characters that represent the string equivalence of this particular example. Int value does exactly the reverse. Int value looks at the string and says, even though this string consists of 3 characters, or as many characters as they are, I'm going to treat them as an integer. So we have to take these 3 ASCII values and convert them into an integer. Once you do it, you can multiply it by 2, as I did here, just in order to dramatize the difference between a character or a string value and an integer value of a bunch of digits that happen to be, or characters that happen to be digits. So if you're not sure what I'm talking about, stop the tape and think about it for a few minutes using the API that I showed you before, and everything will become clear. All right, so that's the client view. And in particular, the 2 most interesting methods here are the setInt method, which turns integers into strings, and the int value method, which turns strings into ints. And what I'd like to do next is discuss these 2 methods, because they are, in fact, the only challenging things that we have to do when we set out to implement this class. All right, so we're going to present 2 general purpose algorithms for converting integers to strings and strings to integers, beginning with int to string. So let's see. We have a particular value, which is an integer, and we want to convert it into a string. So let's take some value as an example. Let's say that the value is 123, which, the number 123. That's the value. We want to convert it to a string. What can we do? Well, we can look at this number and decide that we start with the rightmost digit, which happens to be 3, right? Now, how do we extract this digit from a 16-bit value? Well, we can apply some modulo 10 operation on this value. And modulo 10 always gives you the last digit of any given number, right? If you take some decimal number, if you divide it by 10 and take the remainder, you will get the rightmost digit. So using modulo 10, we are going to extract the rightmost digit. And if the number is just 1 digit, if it's less than 10, we are done. We take this number, we convert it to ASCII, and we return it. That's all we have to do. So let's see, is this what the algorithm says? Yeah, last digit is value modulo 10, and then I take the character that represents the last digit, and if the value is less than 10, I'm done. I return this digit as a string or as a character, and I'm home free. But what happens if it's not less than 10? Well, if it's not less than 10, I have more work to do, right? In this example, I started with the value 123. So I extracted 3, and 123 is greater than 10, so I have more work to do. So now I would like to chop off the rightmost digit and focus on what remains, right? What remains are the digits 1 and 2. How can I chop off the rightmost digit? I can take 123 and divide it by 10. Okay, this is integer division. So 123 divided by 10 is 12. So that's great, because I got rid of the rightmost digit. I have 12. And now I can apply exactly the same algorithm on this 12, right? And I hope that if I apply it recursively, then it will focus on the rightmost digit, which is 2. and then I will focus on the 10, and so on and so forth. I think you got the picture, and here is how I do it. I shorten the input by dividing it by 10, and then I apply the same algorithm to it, and I append the C that I computed in the current method invocation to whatever this algorithm is going to return. So this is a classical recursive operation. As we drill down the recursion, I'm making this thing shorter and shorter. The input becomes shorter and shorter, and in each drill down, I compute the C of the current recursion level. And because recursion, grows the stack, as we learned in previous units, all these C's remain in various levels of the recursion. And as I unwind from the recursion, as I return from these recursive calls, I'm going to do append, 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 and I'm going to end up with a string that holds the character equivalents or the ASCII codes of all the digits that made up 123. So that's how I convert integers to strings. What about the reverse? Well, the reverse is, I think, somewhat easier. We have to convert a string to integers. So what will be the string? Let's say that the string is double quote 1, 2, 3. Okay, so 1, 2, 3 within double quotes. So internally, we are not going to have 1, 2, 3. It's a string, right? So we're going to have the ASCII code of 1, followed by the ASCII code of 2, followed by the ASCII code of 3. The ASCII code of 1 is, I think, as I said before, 49. Then I'm going to have 50 and 51. 49, 50, 51. This is going to be the value of str. Okay? How do I turn it into an integer? Well, it's not terribly difficult. I can start going from left to right, from the most significant character, so to speak, to the least significant character. And if I have 123, or the characters of 1, 2, 3, I can take the left one, which is 50, the ASCII code 50, and I can convert it into an int. That's a very easy conversion. I will get the number 1. Then I remember this one, and I look at the next character. The next character is going to be 50. 50 stands for 2. So what I can do now is take what I had before, which is 1, multiply it by 10, and add to it the integer value of the ASCII code 50. So I'm going to get 10 plus 2, which is 12. Great. Okay. Because remember, the input was 1, 2, 3. And now I shift my attention to the next character, which is the ASCII code of 3, which is 51. And I take the int value of 51, which is 3. And then I take what I had before, which is 12, multiply it times 10, add to it 3, so I get 123. And then I'm out of characters, so I'm done. So this logic, by and large, is shown here on the screen. And if my explanation was confusing, I recommend that you stop the tape and play with some other example. Convince yourself that you understand what's going on. But I wish to remind you that I allow myself to be somewhat remiss about all these algorithmic discussions, because this is not a course about algorithms. It's a course about building computers. And we are now building an operating system. So I don't want to, belabor too much on these algorithms, because that's not the point. The point is to build an operating system. But once again, we have a fantastic opportunity to show some beautiful algorithms. So that's what we are doing here. But it's up to you to decide, how deep you want to delve, to dive into these examples. So here are some implementation notes and advice on how to implement this string abstraction. Well, we have to create objects that represent strings. And if you think about it, you will realize that the most sensible way to do it is to represent any given string as an array that contains character values, integers that stand for ASCII codes. And so this will be one field of the array, one field of the string object, one characteristic or property of the string object is going to be the array that contains all the data of this string. And the other field which makes sense to implement is the length, the maximum length of this, the actual length of this string, which varies from one point to another throughout the string's life cycle. All right, so here's how we construct this string. We have a constructor called new, as usual. The user says, build me a string which is at most 100. So we create an array which is 100 entries long. We set the length to 0 because presently this string contains nothing, and we return the base address of this string to the caller. And that's the new, so that's the constructor. So with that in mind, I think that everything else should be self-explanatory. All these methods that you see here, length, caret, set caret, and so on, can be easily implemented using manipulations of the str array. And int value and set int are jack implementations of the two algorithms that we show previously in this unit. And finally, new line, backspace, and double quote, these trivial functions simply return the ASCII values 128, 29, and 34, which happen to be the ASCII values of these three characters. And that's it. So we are done with the string class, and we'll happily move to the next unit, in which we are going to talk about implementing array processing.